Hi everyone, this video is going to look at the first example in our section 8.3 guided notes about one sample interval for the mean. So the question reads, the Human Toxome Project is working to understand the scope of industrial pollution in the human body. Industrial chemicals may enter the body through pollution or as ingredients in consumer products. In October 2008, the scientists at HTP tested cord blood samples for 20 newborn infants in the United States. The cord blood of the in utero newborn group was tested for 430 industrial compounds, pollutants, and other chemicals, including chemicals linked to brain and nervous system toxicity, immune system toxicity, and reproductive toxicity and fertility problems. There are health concerns about the effects of some chemicals on the brain and nervous system. The table shows how many of the targeted chemicals were found in each infant's cord blood. We want to use this sample data to construct a 90% confidence interval for the mean number of targeted industrial chemicals to be found in an infant's blood. So the first thing that we're going to want to do is ask ourselves the question, do I have quantitative, or in other words, numerical data, or do I have qualitative, or in other words, categorical data? In this case, we're looking at a count of chemicals that are found in the cord blood. So as a result, we're going to be working with quantitative data. This informs us how to answer question A, state your random variable and parameter. I guess it's not so much a question as it is a statement. So for our random variable, because we are dealing with quantitative data, we're going to be working with x bar. And then our parameter will be mu. Since we are dealing with x bar and mu, we know that the first word, or at least the first couple of words that are going to follow the description, say for x bar, will be the mean. The next question that we can ask ourselves is, great, but the mean of what? And if we're careful in reading through the narrative, we can actually pull the information here. We can talk about the mean number of the targeted chemicals that were found in the infant's cord blood. So we can basically borrow that. So the mean number or the mean count, something like that. Of the targeted chemicals found and we need to be specific here, so we just don't want to say in infant's cord blood, because remember, we're talking about the sample when we are talking about x bar, because x bar is the sample mean. So we should call out the count. So in this case, we have 20 infants cord blood. And we can actually take this a little bit further. So we could talk about where the children are from. So we can note that they are from the United States. Now, if we've been pretty careful and deliberate with how we were presenting our description for our sample mean, we basically just have a small edit to make to it in order for it to suddenly be describing the parameter. So instead of specifically 20 infants' cord blood samples, we are going to go ahead and look at all of them. So we really can use what we've written, and we're just going to do that slight edit to get the following. Now, notice that I did do a little bit more editing than that. I moved the from the United States portion of the random variable description, and I moved it up. I think that it just flows a little bit better. So I kind of left my mistakes here so that you can see that you can go back and edit, and you can improve upon it if you need to. And on a quiz or an exam, if you find that that happens, feel free to do a little bit of light editing, include a different color pen with you so that you can show those edits. The other thing, just as an example, because I'm human and I make mistakes, infants, the apostrophe should actually come after the S. I'm assuming that I am correct because, again, degree in math, not degree in English, because we were talking about multiple children as opposed to an individual. So I really should go back and fix those as well. And I can because I have a pen that allows me to do that. So we're going to go ahead and move to verify you have met the 3 assumptions. So before I do that, you'll want to make sure that you have your guided notes in front of you because the directions are going to go off screen. If you don't have them with you, then I would suggest doing a screen grab. Pause the video really quick and go ahead and do that. So we're going to go ahead and we're going to verify our 3 assumptions. The first one that I want to look at is, am I working with a simple random sample? Or in other words, we're going to abbreviate that to SRS. And what we're going to have to kind of say here is we're going to assume that this is a simple random sample because it's not stated in the narrative, just that they had 20 samples of cord blood. The next one that we're going to go ahead and do is check to see if we have a population that is normally distributed, or do I have a sample size that is greater than or equal to 30? Well, this is going to require us to use our calculator to check for our histogram, our box plot, and our normal probability plot. So you will want to make sure that you have your TI-83 or TI-84 handy for what we're about to do. Okay, now that we're in our calculator, the first thing that we're going to want to do is enter in our data. So just as a quick reminder, we should go to Stat, and we should go to Edit. So you can either press 1 or you can press Enter since the cursor is already on the 1. It's already bolded it. So when we press Enter, I've actually gone ahead and I've entered in the data for both the first and the second example. But remember, it's just like an Excel spreadsheet. We're going to enter each number, press Enter, and then move to the next line down and continue to enter our data in. We don't need to have it in a specific order. The calculator will take care of that if it needs to. Now we're going to go ahead and get ourselves set up so that we can do our histogram, our box plot, and our normal probability plot. So we're going to go to second and y equals, and we're going to go into option 1. So again, we can either press 1 or enter in this case because the 1 is already bolded. Doing that, make sure that your stat plot is turned on, and then we're going to come down to type, and I'm going to select the third option for histogram. Press enter, and we'll see that the items below type will change. So right now we're just saying I'm going to pull it from list 1, which is where my first collection of data is located. Frequency of 1, we're not doing a frequency table, so we're going to leave this as 1. And then I will, in this case, leave it as blue because that's the default. So in order to make sure that everything fits on my screen, I'm going to go to Zoom, and then I'm going to select option 9, which is Zoom Stat. And when we look at this image, we can clearly see that we do not have a histogram that is bell-shaped. So I would kind of argue in this case that it might look a little bit different if we had more data. Remember, we only have 20 data points. So just make a note for your histogram, not looking bell-shaped right now, but smaller sample size, which could be playing a big role in there. So let's go back to second and y equals, go back into our stat plot 1, down to type, and this time we're going to look at the box plot with outliers. And again, the 2 little dots here indicates that this is where, if you're looking for outliers, the calculator will call them out in the visual. So we'll press enter. And again, notice that things do change a little bit. You get an extra option called mark. And this is just how do you want outliers to appear on your screen if they exist. I choose to work with the square ones just because it's a little bit more pronounced on that pixelated screen. So again, we'll go to Zoom, option 9, and lo and behold, I don't see any of those little boxes, which means in this case, I do not have any outliers. So that actually works in our favor because, again, we wanted to make sure that our sample doesn't include any of those. So the last one we should look at is our normal probability plot. So again, second, y equals, go back into stat plot 1, come down to type, and we're going to go to the last option here. This is our normal probability plot option. Kind of looks like a straight-ish line. When we press enter, we are going to, again, tell it pull from list 1. The data axis, again, since it'll match up with your homework a little bit clearer, use X in this case. I'm going to leave the marks as little boxes, and blue works for me. So I'm going to do zoom, 9 for zoom stat. And we can see here that for the most part, it looks like it's kind of trending in this nice linear fashion. I'm not really seeing any data points that are like drastically deviating from my work, nor am I seeing like anything wildly different on either end here. Like we're seeing a little bit of curvature on the left and the right side, but they seem to be mirroring each other. So I would say that this is roughly linear. All right, let's go back to our notes. Okay, so I have our results summarized from our work on the calculator. So now we're going to move into our third assumption. And our third assumption states, do we know sigma? Or in other words, do we know the population standard deviation? And the answer to that is we don't know it. So now that we've gone through these 3 checkpoints, this is now going to inform us how to answer part C. Which procedure will you use in this situation? Well, we're assuming normality, however, we don't have access to the population standard deviation. The only thing that we can do is work with the 20 data points that have been supplied to us. So at best, we can come up with a sample standard deviation. So as a result, we're going to create a t interval. Now we'll go ahead and move to part D, where using our calculator, we're going to determine the sample mean and the confidence interval. Okay, now we are ready to construct our t-interval for our data. So remember, we are going to go to stat. We're going to arrow over to tests. And remember, we want the t-interval, not the t-test. The t-test is for a hypothesis test. We are interested in constructing a confidence interval. So we're going to select option 8. And in this instance, we're going to have it pull from data because, again, stats is if we already have that information ready-made for us, or if we wanted to do our own calculations to find the sample standard deviation and whatnot. So in this case, I am going to have it pull from list 1. Right now it says list 3. So what I'm going to do is I'm going to press second and 1. And as you can see, there's a little blue L1 above the 1 key, and that's what tells me that I should press that key after I hit second. So frequency, again, will stay 1. And then we want to do a 90% confidence interval. So we're going to change that 5 to a 0, or you could just delete it out. And then we're ready to go, and we'll hit calculate. And there's our solution. As before, I've gone ahead and I've summarized our findings from our calculator below. So now that we have all this information, we can move to our conclusion. So I'm just going to scoot this up a little bit. I'm going to keep my parameter definition in view. So remember, there are about 4 things that I want to see in your conclusion. 1, we want to talk about the confidence level that we used, because again, we don't use the same confidence level in every single confidence interval question. I also want you to call out the fact that we're looking for a mean in this case. So we should see the word mean or average literally written in there. We should have context. So we should be referring to the particular situation that we are investigating or studying. And really those last 2 points, you can pull from your definition of your parameter that you created. And finally, and pretty importantly, we want to include the lower bound and upper bound of our confidence interval. So we should say something along the lines of, we are %90 confident you can say true mean or population mean, something like that. And now I'm just going to go ahead and continue to copy what I have above at the top of the screen. Number of the targeted chemicals found. There we go. Now that looks like an O. In all U.S. infants, cord blood is between 117.41 and 137.49. And that's essentially it. So again, we've called out the confidence level. I then referred back to the definition for our parameter and then pulled our values from the confidence interval that we calculated. And there you have it. We're all done.